Video is about the rational root theorem. Before we talk about the rational root theorem, there's some vocabulary I want us to remind ourselves about. So, I would create a section in the back of your binder with just vocabulary, and this is where I would write these vocabulary words. First vocabulary word, integer. It's a noun. An integer is a number like 1, 2, 3, 4, 5, 6, 7, or negative 1, 2, 3, 4, 5, 6, 7, or 0. So basically, it does not uh, have any decimals in it. Next word, rational number. A rational number is anything you can write as an integer divided by an integer. For example, the number 3/2 would be a rational number, or negative 1/2, or 5/1. Those would all be rational numbers as long as you can write it as an integer divided by an integer. Okay? So if that is what a rational number is, an irrational number is a number you cannot write as an integer divided by an integer. Examples of that would be, for example, pi. It's a number 3.14159 dot dot dot. It keeps on going. This number, these numbers here never repeat. So it's impossible to write it as a fraction. Another example is this thing we call e, which is 2 point, once again, numbers that never repeat. Another example would be the square root of 2. This equals 1.4 something something something. And once again, we cannot write this as an integer divided by an integer. So those are examples of irrational numbers. Next word I want to go to is imaginary. Imaginary numbers are basically things that have the square root of a negative. For example, square root -1 is an imaginary number. We write the symbol for square root of -1 as I. So if you ever see something that says 5i, that'd be an imaginary number. Or the square root of -4 is an imaginary number. Square root of -5, imaginary number. Next vocabulary word, root. A root is a value for x that will make the y equal to 0. Continuing, theorem. So we're talking about the rational root theorem today. That word theorem is a rule that has been proven to be true. Okay. 2 more words. Constant term. A constant term is a term made of just a number. So for example, the number 5 is a constant term. -12 is a constant term. If you have a polynomial, for example, if you have 3x squared minus 4x plus 10, this positive 10 here is the constant term. It's a term made of just a number. Next word, leading coefficient. The word coefficient means the number in front of the x. So in this polynomial we just talked about, this 3 is a coefficient. This -4 is a coefficient. And a leading coefficient is the coefficient for the term with the biggest exponent on the x. So because this term is our leading term, because this term has the biggest exponent on the x, our 3 is our leading coefficient. Our 3 is our leading coefficient. All right. So we're going to need those vocabulary words for today's lesson. Pause the video if you need to. And let's move on. So we are talking about the rational root theorem today. So it's a rule that's been proven to be true about the values for x that make y 0 that happen to be rational, that happen to be something you can write as integer over integer. Here's the more formalized definition. So rational root theorem, if you have a polynomial, f of x equals ax to the n plus bx to the n minus 1, etc., 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 all the way to cx plus e. Here the capital A, B, C, and E are numbers. And then you have the n, and the next one is n minus 1. So for example, if this was x to the 3 power, then this would be x to the 2 power, x to the 1 power, no x's. So if you have this polynomial f of x, then the only possible rational roots is some integer that multiplies to equal e, your constant term, divided by an integer that multiplies to equal a, your leading coefficient. Okay, let's do an example of this. Let's say you are asked to determine or find the roots of this polynomial f of x. Once again, the roots is the values for x that makes the y equal to 0. So, first of all, what are the integers that multiply to equal our constant term? So, our constant term is our -3. So what numbers multiply to equal -3? Well, you have +1 times -3 or you have -1 times positive 3. Those are the only ones. Okay, so next, what integers multiply to equal our leading coefficient? Leading coefficient is the coefficient next to our leading term, or next to the x with the biggest exponent. So here our leading coefficient is 2. What number multiplied equal 2? Well, positive 1 times positive 2, or negative 1 times negative 2. All right, so let's go back to our original question now. Our original question asked you, what are the possible roots for that polynomial? So we're going to use the rational root theorem to look at the rational roots, or the possible rational roots. So the possible rational roots are going to be a combination of these here in red divided by these here in black. So our possible rational roots is, for example, positive 1 divided by 1, or positive 1 divided by 2, positive 3 divided by 1, positive 3 divided by 2, and then all the negative versions of that. Let me write that down here. So once again, it is positive 1 divided by positive 1 or positive 1 divided by positive 2. We also had positive 3 divided by positive 1. Positive 3 divided by 2. I'm writing them like this just to keep them organized. We also had the negative versions of these. We had I'm just going to write the ones I wrote here. So we had negative 1 so negative 1 divided by positive 1, negative 1 divided by positive 2, negative 3 divided by positive 1, negative 3 divided by positive 2. Technically, we also have the combination negative 1 divided by negative 1, which will just equal this right here, or negative 3 divided by negative 1, which just equals this one here. Okay, so if there is a rational number, that makes the y equal to 0, a rational number for x that makes the y equal to 0, it's going to be one of these 8. I'm going to simplify our ones up here a little bit. 1 divided by 1 is just, well, 1. Negative 1 divided by 1 is just negative 1. Positive 3 divided by 1 is just positive 3. Negative 3 divided by 1 is just negative 3. Okay, so now we need to find out which of these 8 here can make my f of x equal to 0. So you place 1 into f of x, which is another way of saying you're finding f of 1. And if I replace all the x's with 1, this will end up giving me 0. If I replace all the x's with negative 1, that would give me y equal 4. If I replace all the x's with 3, y would equal 84. If I replace all the x's with negative 3, y would equal 0. Same thing with these. If I replace everything, all the x's with 1/2, y would be negative 3.5. If I replace all the x's with negative 1/2, y is equal to 0. F of 3 over 2 is equal to 9. F of negative 3 over 2, y would be 7.5. All right, so it turns out that the rational values for x that would make the y equal to 0, well, are x equal 1 is a root, because that makes the y, when x equals 1, y is equal to 0. When x is equal to negative 3, y is equal to 0. And finally, when x equals negative 1/2, your y is equal to 0. So these are your 3 roots. I know there's going to be 3 roots because the biggest exponent is a 3. Just for the record, this only shows you all the rational roots. There might be roots that are not rational. Okay, so if x equals 1, x equals negative 3, and x equals negative 1 over 2, if those are your roots, then I know that x minus 1 will be a factor, x plus 3 will be a factor, and x plus 1/2 will be a factor. Another way of saying that is I know that my f of x divides evenly with each one of these. When I divide my f of x by this, there will be no remainder. If I divide my f of x by this one, x plus 3, there will be no remainder. Same thing with x plus 1/2. Okay. So, last thing. If you are asked to factor this. This word factor means change it to be something multiplied by something. So if you're being asked to factor this, well, I just found, when I found my roots, I also found factors. So I can write this f of x as x minus 1. I know another one of the factors was x plus 3. I know another factor was x plus 1/2. If you'd only found one of these, let's say you'd only found x minus 1 to be a factor, the way you can find the other part is by doing f of x divided by x minus 1, doing the long division. One final thing I want to point out here is that if I were to multiply these three red things together, right now I actually do not get that. Right now, if I were to multiply these three together, I would actually get x to the third power plus 2.5 x squared minus 2x minus 1.5 if I multiply these three parentheses together. What you have to do to finish making this line here equal to our f of x is that you'd have to multiply in the front by 2 because of this 2 here in as your leading coefficient. So now these three lines are equal to each other. Just to clarify, when you're asked to factor, this is what they are asking you to do. That particular line, you're asking to change this into something times something. Here I was able to change into parentheses times parentheses times parentheses. Sometimes you only have two parentheses that you're able to do.